Okay, guys, just want to talk to you guys a little bit about Chapter 7 and the things that were discussed in Chapter 7 and the special types of IV calculations. For the most part, the number one thing we're looking for in this chapter is figuring out how to set the infusion pump, which is setting the infusion pump means, again, milliliters per hour. We briefly talked about that in Chapter 6 when we were looking at your basic IV calculations. That was one of our formulas. Those were really easy because what we were told in those problems is we were given, say, an ordered amount, and what was ordered was, say, 2,000 milliliters over, let me put milliliters correctly there, 2,000 milliliters over, say, 8 hours. Well, that was really simple because all we had to do was take 2,000 milliliters and divide it by 8 hours, and that gave me milliliters per hour. I didn't have to do any converting or anything. It was already pretty much given to us in that problem as milliliters and hours. And then when I took 2,000 divided by 8, okay, that told me that they're receiving that IV at a rate of 250 milliliters per hour. So that's what we looked at in Chapter 6. A little bit different in this chapter. The only difference is it's ordered differently. Instead of, being told that we need to give so many milliliters over the course of so many hours, instead, we're seeing things like, okay, well, this patient needs so many units per hour, or perhaps so many milligrams per hour. So if the end goal is to get to milliliters per hour, but it's ordered a different way, we have to have some other information given to us in the problem that tells us how we can get to this. This is our end goal. For instance, in the first section, we talk about how when medications are ordered in units per hour, so say something like this. If it's ordered in units per hour, how am I going to get to here? Or perhaps even milligrams per hour, where it's given as some type of dosage. We want to get it to liquid form. So we've already, hours are good. It's already, what's been ordered is already per hour. So that conversion's already done. But how do I get from units to milliliters? How do I go from a solid dose to a liquid dose? And so what's going to have to happen in here is there has to be some type of known for that medication. It has to tell us, oh, well, actually, there's so many units per so many milliliters, and if that's the case, then that will help us to get there. Let me show you what I mean. Say, for instance, okay, so in some of the examples we looked at, let me get this out of the way and show you what I mean. So some of the examples we talked about, say if, let's say a doctor orders, let's say 800 units, I'm just going to write 800 units per hour. And what's available, it says on the label, so we'll say this is what I'm going to write here in blue, what's on the label. And it says that heparin is available as 40,000 units in, sorry, my handwriting's terrible, in 1,000 milliliters. Okay, so what's the rate? Well, so there's this right here, this becomes our known. This is what we know about this particular medication, that there are 40,000 units in 1,000 milliliters. So what happens is it becomes a D over H times Q formula, because we know, and that's our dosage formula. Remember, D standing for what the doctor's order is, H as the dosage that medicine comes in, and then Q is the quantity per dosage. So in this particular problem, what we have is our doctor's order is 800 units, and that our H is 40,000 units. And again, sorry, my handwriting is just terrible, is 40,000 units. And keep in mind, too, that the order dose is already per hour. So we're trying to get it to milliliters per hour. So since this order dose is already per hour, there's no need to have to convert, our time in this case. So all we're doing is incorporating the medication. It's 800 units per hour, but since it comes in 40,000 units per 1,000 milliliters, there's our quantity. When we take this and we divide this out, 800 divided by 40,000, and then multiplying that by 1,000, that gives us 20. And again, what we've done is what happens to our units. Remember, I'm sorry, our units in this case, yes, our units cancel out. leaving me with milliliters. So we just converted that 800 units to milliliters, to 20 milliliters. And since that 800 units, again, was already per hour, the 20 milliliters that we have here is also per hour. So we just converted it to 20 milliliters per hour. That's what that person would need as far as that particular infusion rate. Taking a look at another one. Okay, let's say we have, let me get this out of the way here. Let's say doctor's order was, instead of units, let's say they've ordered it in milligrams or, some type of other form of, again, a solid dose. So let's say we have, a physician orders, order, I don't know, let's say they've ordered 1,000 milligrams per hour. Okay, so we know what it is in milligrams per hour. End goal is to get it down to milliliters per hour. So we need to know how this medicine comes in order to get it from milligrams to milliliters. So say we look on that label and it says that we have, on the label it says that this particular medication is, I don't know, let's just say 250 milligrams per 5 milliliters, let's just say. If that's the case, and that's what's going to help us to get, that becomes our known. That's what we have here. So that's going to help us to figure out, okay, how do we get from milligrams to milliliters? And so, once again, it becomes a D over H times Q formula. We've got 1,000 milligrams that we've ordered. It comes in 250 milligrams per 5 milliliters. So once again, this D over H times Q formula is going to help us because milligrams will cancel out, leaving us with milliliters. And since that order dose was already per hour, when we convert this to milliliters, it too will already be per hour. So we just take 1,000 divided by 250, which is 4 times 5. This coincidentally is also 20 milliliters. So we just got it down to 20 milliliters per hour. Again, that's the idea, is just to make sure that what we have will help us to convert that from a solid to a liquid, because that medication comes in liquid form. The doctor here has just ordered the amount of dosage that they need. So very, very similar to what we saw in our dosage calculation questions. And so another thing to keep in mind is, remember, when doctor's order is in grams, but it comes in milligrams or what have you, we want to make sure that we're converting that the correct way. So if, doctor orders so many grams per hour, make sure that we get that to milligrams if that's how that medicine comes. We looked at that in our dosage formula, or in our dosage chapter. What I mean by that, if say the doctor's order is 2 grams, and that medication again comes in, and say again 2 grams per hour, and let's say that medication comes in 1,000 milligrams per milliliter, something like that, then I can't divide this out, because as 2 grams and 1,000 milligrams and grams wouldn't cancel each other out there. So what I'm going to have to do is, as we did in our dosage chapter, we're going to convert these to milligrams to get them to where they line up. This way now we can see our unit. Milligrams will cancel out and will get me down to milliliters. So we talked about that a handful of times already. So just don't forget that when you're doing these dosage calculation formulas. Another thing to keep in mind, so far we've looked at if it's ordered as units per hour or milligrams per hour or grams per hour, but what happens if the doctor has ordered a dosage but instead has ordered it per minute? What happens here now, let's just take into account, let's just say doctor orders 5 milligrams per minute, and we need to figure out what their flow rate's going to be, or their infusion rate. Remember, that infusion rate is milliliters per hour. So now we have 2 things we have to convert. I have to figure out how to get milligrams into milliliters, and I have to figure out how to get minutes into hours. Super, super, super easy. What we're going to have to do up there at the top to get our milligrams into milliliters is we have to be told how that medication comes. So again, looking at the label, taking a look to see what what our H and our Q are in that case. So that's going to be where that D over H times Q formula comes in. And then to get from minutes to hours, keeping in mind that there are 60 minutes in an hour. So if they're taking so many milligrams per every minute, they're going to do that 60 times in an hour. So we're going to end up here multiplying by 60 in order to figure out, what that would be per hour. So again, like I said, if it's 5 milligrams per minute, and you can do this however you guys choose. Remember, the order doesn't necessarily matter. You can do the times 60 first, or you can go ahead and incorporate the D over H times Q formula, up to you completely. I'm going to go ahead and just take a look at that label, and let's say if doctor orders 5 milligrams per minute, let's just say the supply dosage is, and even just to make things even crazier, let's say the supply dosage is, let's call it 1 gram in 500 milliliters. So there's what's on our label. So that's our, our supply dosage there. So we know that that's what's going to help us to get from our solid ordered dose of milligrams to the liquid form. So, like I said, it doesn't matter what order you choose. I like to sometimes think, okay, well, if they're getting 5 milligrams per minute, they're going to do that 60 times in an hour. So therefore, that would equate down to 300 milligrams per hour then. So that might, help you just in thinking what that could be, and just right off the top there, that helps us to get it to hours. So we're already done with this part. Now all we need to do is incorporate that label and how that medicine comes to get it into milliliters. So that's where that D over H times Q formula comes in. Our order dose is 300 milligrams. That comes in, well, it says 1 gram, but keep in mind we need it to match. So 1 gram would be 1,000 milligrams. So I'm going to use that in this problem here, per 500 milliliters. So I'm going to take that and divide that out. 300 divided by 1,000 is going to give us 0.3. Multiplying that by 500 gives us 150. So the flow rate in this case would be 150 milliliters per hour. So that's all that has to happen here. Just remember, keeping in mind 2 things. We need to get it, that dosage that's been ordered, we need to get that into liquid form. So by doing a dosage calculation, and we may need to also remember minutes to hours. So let's see, let's take a look at another one. And remember, making sure that they match appropriately. So if I have, for instance, let's say doctor orders, how about 400 micrograms per minute, and I need to get it to milliliters per hour again. Keep it in mind, same thing has to happen. We just need 2 things that have to be adjusted here. We got to get our micrograms into milliliters, and we have to get our minutes to hours. So we look at that label, and let's say the label says that this medication comes in 400 milligrams per 250 milliliters. Okay, so that's what's going to help us up there at the top. That's what's going to help us to get from our micrograms to milliliters. And then remember, minutes to hours. If it happens, if it's 400 micrograms in a minute, in every minute, that's going to happen 60 times in an hour. So that's why we end up multiplying by 60. And again, up to you on which one you adjust first. If you want to go ahead and do that dosage calculation first, you can. This is the opposite of what we did in the previous problem, but I want to show you guys that it doesn't matter either way. What happens here, if I do the dosage calculation first, remember we need our D and H to match. So here's doctor's order, 400 micrograms. What we have is 400 milligrams. So we may need to do some adjusting here. So I'm going to go ahead and just convert the micrograms into milligrams. Okay, so our order dose, which was 400, is now 0.4 if I'm getting 400 micrograms into milligrams. Remember, micro to milli, guys, is 3 places to the left, or divide by 1,000 if you're using that stair-step method. And so that's what I changed here, is that doctor's order into milligrams. Because on the label, it says there are 400 milligrams per 250 milliliters. So if I went ahead and did this first, we can take 0.4 and divide that by 400. That's going to give us 0.001. Multiplying that by 250 gives us 0.25. Now what I've just calculated, since I haven't, so that is in milliliters, but keep in mind that originally that order dose was per minute. I'm going to circle this up here in yellow so you guys can see that that was per minute. So therefore what I just calculated here was milliliters per minute. So that's how many milliliters they're getting per minute. All we've done so far is done that top conversion, getting it into, from that dosage into liquid form. Now I need to figure out how many that would be per hour. So once again, because that happens 60 times in an hour, this 0.25, I can just go ahead and multiply that by 60, and that would give me 15. So it would be 15 milliliters per hour. Like I said, doesn't matter which one you do first. Some of you guys may have looked at that and said, oh, well, they're getting 0.4 milligrams every minute. 0.4 times 60, guys, is 24. So therefore, if I'd have done that first, so let me just erase some of this just to get this out of the way to show you guys what I mean. Oh, I didn't mean to erase that 250. So just to show you guys what I mean, if we did that first, if we said, okay, well, 0.4 is what they, again, we've just converted the 400 micrograms of the original order dose and converted it into milligrams, which is 0.4. Well, if they get that 60 times in an hour, again, because it's 0.4 milligrams per minute, times 60, that would be 24. So therefore now what we've just converted is the order dose into 24 milligrams per hour. So I could have used that in place of our dosage calculation, and if I did that, you'll see that you'll still end up getting the same thing, that 15 milliliters. So 24 divided by 400 is 0.06 times 250 is 15. So we still get 15 as the end result no matter what you convert first. Like I said, originally, at the very beginning, our goal is to convert those two things. It was originally, well, if I could find a pen here, it was originally 400 micrograms per minute, and we need to get it to milliliters per hour. So we just need to convert those two things, and that's what I mean. It doesn't matter which one you convert first, if you go ahead and do the dosage calculation first, or if you go ahead and multiply by 60 first. You have to do both of them. Doesn't matter which one, though. And just with doing the dosage calculation, just keep in mind, D and H have to be the same unit. So that's why we ended up having to convert it to 0.4 in the beginning. So that's what happened there. Very, very similar is, when we throw in per kilogram too. When we've talked about this a little bit already. Or no, I'm sorry, we'll talk about this this class, in today's class. But what's going to happen when we throw in, say, per kilogram? So like the ones that are on page 272, it gets to where it's ordered as micrograms per kilogram per minute. Those were a little bit trickier, but the same concept is happening there, that if, say, we ordered micrograms per kilogram per minute, and I'm writing it this way just to show you guys that in order to get it down to milliliters per hour, we've got three things we have to change. What has to happen is we have to incorporate the patient's weight, so that, we're not converting that to anything over on this side. We just have to incorporate the patient's weight, so we're going to have to multiply by that weight, whatever it might be. And then, just like we were doing in the previous questions, we're going to have to just get that dosage from micrograms into milliliters and minutes into hours. So it's really kind of the same thing that we were doing before. We just can't forget to incorporate that patient's weight in these questions. So let's take a look at these. Let me get an example out of the book here. I'm going to grab the one that's actually on page 272 if you guys happen to be looking and following along with me. In that particular example, dopamine was ordered as 2 micrograms per kilogram per minute. So again, those three things that we need to incorporate. As I mentioned to you guys before, there is no particular order that you guys need to go in when you are converting these. You can do your dosage calculation first in changing those micrograms into milliliters. You can multiply that patient's weight first if you want to, or you can multiply by 60 in order to get it from minutes to hours. It doesn't matter which one you choose to do. We just need to make sure that we do all three. So let's do that. So if they've ordered 2 micrograms, I need to look on the label to see how that medicine comes in order to get it out of micrograms and then get it into milliliters. We're going to need to do a dosage calculation for that one. So I look on the label and it says that this particular medication, and we're looking at dopamine in this example, comes as, what does it say, 200? Yeah, 200 milligrams per, looks like per 250 milliliters. So there's our H and our Q, but we need to keep in mind when I'm doing that dosage formula, since the doctor had ordered 2 micrograms and our H and our Q here are 200 milligrams and 250 milliliters, I need to get them to where they're the same unit, so I'm going to convert those 2 micrograms into milligrams. That would be 0.002. Yeah. So I know that seems kind of strange, but that's going to help us to get from, again, that unit dose of micrograms now into milliliters. So right now it's, again, like I said, we just need to make sure D and H are the same unit. So I'm going to go ahead and take 0.002, and I'm going to take that and divide by 200, and then take that and multiply by 250. And that, again, seems like a small number, but again, we still have 2 more steps that we have to complete. It's 0.0025, but it's in milliliters. And again, right now, it's milliliters per kilogram per minute because we haven't done anything with those 2 parts up there. So let me go ahead and just get some of this stuff out of the way. We've done step 1. It is now, like I said, it is 0.00, let's see, let me write this down up here. 0.0025 milliliters. We got it into that liquid form, but again, we still need to incorporate the weight and the time. So I'm going to go ahead and incorporate that weight. Looking at this, it says that the patient weighs 176 pounds. 176 pounds. Okay, but it's per kilogram, so we need to make sure that patient's weight is in kilograms. Remember, our equivalent for, our known for pounds and kilograms. Remember that 1 kilogram is equivalent to 2.2 pounds. So that is, in this particular conversion, in order to get that to kilograms, then remember that is a smaller to larger conversion, so I'm going to have to divide by 2.2. So we take that and we divide by 2.2 in order to figure out what that is in kilograms. 176 pounds divided by 2.2 is 80 kilograms. So what that means is if this patient needs 0.0025 milliliters for every kilogram that they weigh, they're going to need 80 times that amount. So I simply just take that and multiply my 0.0025 by 80, and that gives us the answer of 0.02. Oh, not 0.02, I'm sorry, 0.2, guys. So what that is now is 0.2. We've got it in milliliters already. We've already incorporated the kilograms. It's 0.02 milliliters per minute. And again, now my last step, all I have to do is get that into hours. If they're getting 0.2 milliliters every minute, they're going to do that 60 times in an hour. So I'm going to take that and multiply it by 60. So 0.2 times 60 would give us 12. So this person gets 12 milliliters per hour. Okay, guys, I hope that helps. That should cover everything that's included on today's quiz. So best of luck to you guys. And we'll go over, after the quiz, we'll go over some dosages. All right, thanks.